Hello, this is Britjet's PSX Tips, the Aerowinks PSX Boeing 747-400 desktop simulation. Today the second non-normal video, this one about the use of the QRH. The QRH, Quick Reference Handbook, contains non-normal checklists, unusual maneuvers, performance for the aircraft and other operational information which may be needed in flight. This particular one, downloaded from the internet, contains reference to the Pratt & Whitney engines, so if you want to download one, make sure you get one for the aircraft type that you are using. So let's agree between ourselves that we're not going to call this an emergency checklist. In fact, the only thing that's likely to cause an emergency is ourselves and how we react to any non-normal situations that we find in the aircraft. So perfectly normal to have a non-normal, if you understand what I mean by that. And at this stage, many of you who are flight simmers will probably be thinking, well, I can't be bothered with that. I'm just going to reset things, cancel the fault, and carry on with my planned flight as though nothing had happened. But I would urge you to come back on that. The QRH is designed by Boeing, by many experts over many hours and days for each section, of course, to ensure that people who are not terribly competent with the aircraft can nonetheless carry out a professional recovery of a non-normal situation. And the briefing today will be as though you were a normal, competent multi-crew acting in a professional manner, like these three here. The QRH, in fact, has only got 10 memory items where you might have to press the big red button, as it were, and 6 of these actually are for the engine, so there isn't very much. The rest of them can wait until a suitable time in the flight when you call for the appropriate non-normal checklist on the QRH. So coming to the QRH in more detail now, this is the front cover you're likely to find. Let's go inside and see what there is. On the front page you'll get something called a quick action index. Listed here are all the things that are likely to get you into trouble unless you do something quickly, and all the incidents and accidents that have happened to aircraft over the years, most of them would be found on this very front page, I think you'll agree. They're not all memory items, they're simply the quick action items, and then on the right hand side over here you see that there are a list of references so that you can quickly get to the section that you want. The next index down will be the ICAS messages, which is probably the most useful one, and it's simply an alphabetical run through all the various messages you can get on the ICAS. Some will be in bold and they will be the memory items that we've talked about. So that will go all the way through. After the ICAS messages you get unenunciated checklists. Now this is quite an important page because unless you know it's there, you're not going to be able to find anything that doesn't happen on the ICAS. For example, ditching. How to deal with a ditching, what to do down below if the gear lever is jammed in a certain position, and I think you get the idea now. So things which are not on the ICAS will be in here, again with references. And just when you thought you'd had enough of indexes, we now go through the whole lot in alphabetical order, like this. So this will include the unenunciated and the ICAS messages together. At the completion of that, we have just a small page where they've included the specific normal checklist for that particular airline, and then below that, miscellaneous, anything else they want to chuck in. And then below that, we start here with the items, which I'm following through with the mouse pointer, to show that it follows alphabetically through the aircraft systems as they are found in the technical manual. So you've got fuel, hydraulics, landing gear, warning systems at the end. And if I pull up a page, for example, here is the engines section, section 7. The memory items, if there are any, will always be at the very top, separated by a black dotted line, and then the rest of it follows in alphabetical order again for anything that you need to know. The listing carries all the way down, and eventually we get to a thing called operational information, This may or may not have anything in it, but sometimes it will have useful information that's been presented by the airline, which will include things like how to do an auto land in bad weather, how to fly an RNAV approach, for example. There may be nothing, or there may be something in there. And then below that, you have the performance in-flight section. This particular in-flight section is for Pratt & Whitney engines. And looking through the table of contents at the beginning, you can see we have some items here, non-normal and normal. So you will be consulting this both for a non-normal situation, but also just for general operations. For example, there's a table there with VREFs, and here there's one for normal configuration landing distance, so you can work out, for example, how much auto brake to use on landing. And then we have inoperative stuff like gear down, on engine inoperative, moving on down, long range diversions and so on. But it doesn't look like very much, but there's actually quite a lot of information in there. One I'll bring you to, first of all, the normal configuration landing distance here. Quite a useful table. This is for flap 30, and actually over the page there will be one for a flap 25 landing, like that. The braking configuration is fairly self-explanatory. If you're going to use one of these tables, and they are a little difficult to use, then always make sure you read the text at the bottom, because there's actually some additions that have to be added to any landing distance that you come out with. So that's one example. Let's come to another one. The brake cooling schedule is another useful one. Basically what this is telling you is how much your brakes are going to get hot in the event of a rejected takeoff. Now, the brake cooling schedule enables you to find out in advance what's going to happen to your brake temperatures. They take about 15 minutes to stabilize. It'd be nice to know before it happens what they're likely to reach. So we can do that for a rejected takeoff or for a landing, typically an overweight landing. Let's look first at the rejected takeoff case. I'll take an example here of 350 tons. I need to know my brakes on speed. Now I can either use indicated airspeed like here, or I can use ground speed. If I use indicated airspeed, then I have to use these little boxes here, all these little boxes, to go into with outside air temperature and pressure altitude in order to obtain a related figure. However, if I have my ground speed, I don't need to do that. I can just use 15 degrees and sea level. So for 350 tons, a stop at 80 knots would put me with that fella there, 18.8. Let's suppose we reject at 120 knots ground speed, so that would be there, 36.8. You remember that figure, and now you go down through the table to the next page, and you'll notice here there are two sections, reverse thrust and fore-engine reverse. For a rejected takeoff, no account is taken of reverse thrust, so that's a bonus, and it's not reflected in the table. So 36.8, I come down to my reference brake energy here, which would be 36.8, so nearly 40. Let's use 40. And now I go down, no correction, because it's a rejected takeoff, and what we have here is 40. Now I go below that to this table called cooling time, and 40 on here will bring me to somewhere in the caution range. The caution range means there is a chance of a fuse plug melt, and you should stay clear of the tyres. The brake temperature monitoring system, BTMS down here, will be indicating something between 5 and 6 on the ICAS. So we're probably okay, but we'd have to take things carefully. There is a chance that we might have fuse plugs melting. And that's how you'd use it for a rejected takeoff. Now for a landing, it's very similar. It's the brakes on speed. So let's assume we are landing overweight at 300 tons here. And we have a number of options for brakes on speed. And you remember your half mv squared, you'll see that the speed at which you put the brakes on makes a big difference to how much brake energy you accumulate in millions of foot-pounds. That's something to think about. So the bottom line is always use as much runway as possible. Let's suppose we're going to put the brakes on at 140 knots. and we're going to use ground speed, so I come with a figure here of 41.6. Now we go down. I have the option for using no reverse thrust, but let's assume we're going to use all 4 engines in reverse. 41.6, just above 40 then, so I'll come down the 40 table, and now we have choices of the amount of auto brake we use. You can see that the amount of auto brake we use makes a significant difference to the brake energy, as does the reverse thrust. So if you look at the figure here for using no reverse thrust and the equivalent figure for using reverse thrust, you can see how important reverse thrust is here. So you would tailor your auto brake and your reverse, and indeed your brakes on speed possibly, to make sure your brakes are as cool as possible. Let's suppose I go for auto brakes with 4 engines in reverse, auto brakes on 4 because we've got a short runway, 29.8. Now I go into the cooling thing here, so 29.8 is very nearly 30, isn't it? So we'll go over here, and what it says now is that we are in fact below the caution range, so we are just okay. The figure to stay out of obviously is the 34 figure here, which would be the start of the caution range. I'll also mention there are a whole load of information down here which will take into account extended taxi time and so on, so it's always worth a read. Just on the subject of how much braking to use for landing, this is the normal configuration landing distance, flap 30. You'll see we have options for braking action, options for how much auto brake we're going to use, this table working in feet as you can see, and a whole load of adjustments, weight, altitude, wind, slope, temperature, etc., and how much reverse thrust we use. And there are notes at the bottom which also are worth a look because they also affect the grand total that you will come to after you've added up all these little numbers. Just highlighting a few points about checklist use then. First of all, this section here, only a few situations need an immediate response. The rest of the time you can sit on your hands and really wait until the flight path is under control and you're not in a critical phase of flight and you've got rid of the memory items. So no rushing. Next thing is you'll find a thing that says confirm sometimes. This is when something gets moved, it causes a catastrophe, it's the wrong switch or lever, and there's a list of the ones here which will be affected by that. So you must always confirm those before you actually move them. And moving on down, you'll see something in the checklist which quite often says checklist complete except deferred items. These will be things that will be happening as you approach descent, approach and landing, and what it will do then is require you to use the QRH as your descent, approach and landing checklist. So you throw away your little thin normal checklist and you use the big checklist, because there may be differences which will be in bold type. And at the end of the checklist you'll find something that says it's complete with the 4 squares printed like that. There is also a short legend here to show you some of the symbols that are used in the QRH. I'm not going to go through them in detail here, but the page is here for you if you want to pause it and have a look at it. Let's run through a typical checklist then. IAS disagree, ICAS message. Various ways of getting to it through the index. I've chosen the ICAS messages here. I find ICAS disagree in section 10, the flight instruments section. I go to that and I get disagree in capitals, meaning it's ICAS, or we could just get unenunciated airspeed unreliable. Condition and objective, no need to read through every single word in this, just make sure this is the correct checklist for you. And then you'll see there are some memory items here because they have the dotted line below them. So these would be accomplished before you even got the checklist out. Once the checklist is out, go through these again, make sure you've done everything, and then start going through the numbered items on the QRH. No need to call out the numbers, and no need to overdo the verbiage on this, it all takes time. You go through them in sequential order, and you'll notice here there is a choose one option. Option 5 here might finish up with the checklist complete, or if it carries through to the other option, you can see we carry on down to referring to the flight with unreliable airspeed table in the QRH, and then checklist complete except deferred items. So it then gives you a list of helpful stuff to help you get the thing on the ground in one piece, and below that the checklists that remain, which will now be used instead of the normal checklist itself, As I said before, anything different would be in bold writing here. And finally, checklist complete symbol at the bottom. We're not quite finished because it says continued on the next page, when it will give you additional information, some useful stuff which might make sense to you in the situation, as well as some likely ICAS messages. So there you are. Here's your chance to be a hero now, like Captain Bill Hagan here of British Airways. It's always the captains that are heroes, as you've no doubt noticed. Co-pilots never get mentioned, unfortunately, but that's life. The next video in the sequence will be about human factors, how flight crew can get the optimum performance out of a non-normal situation. Thanks for watching. Bye for now.